So let's look at this one here. So we know that the standard form of a quadratic equation is ax squared plus bx plus c, right? Where a is my leading coefficient, c is my constant, b is the term that is always with just the plain old x. Well, we'll have to watch it. All right, so again, so now I'm here. Right now, this one is not going to factor, just like the last one did factor. Right? But what do I wish that this negative 3 was? We wish that it was a positive 25, right? Because, so I'm just going to change it. I'm making it what I want it to be. Well, it's not, though. It's an equation. So what I did is I made a change to the one side. Now it's out of balance. So what did I do to turn this negative 3 into a positive 25? I added 28. Well, if I add 28 to the left, then I better add 28 to the right. Okay. Now that is not necessarily ideal for solving because we like them when they equal 0, but this isn't bad because now this will factor. So let's just act like it was a 0 over there for now. We'll just ignore the fact that it's a 28 ugly. All right? So what will this thing factor over on the left then? X and X. I know that. Signs? Okay. And that's why we picked that 25 in the first place. So how can I rewrite that? Okay, now, something good just happened. Well, I'm not done. What's the good thing that happened? Do I have an x squared anymore? In fact, how many x's do I have? I got it down to 1 now. Well, we've been doing that since algebra 1, right? Getting x alone. So how would I start getting alone now? Right, I got to get it out of that parentheses first, so I need to square root this. But if I square root that side, I got to square root this side. So what will I be left with over here on the left after I square root the side? X plus 5. How about over here? Any perfect squares in 28? 7. I'm going to get 2 radical 7, but really a plus minus, right? Now what do I do to get x by itself? From both sides. So I'm going to get x equals a negative 5 plus or minus 2 square root of 7. Solve. Radical x.
Writing the square root.
Here?
Yeah.
I took the square root of all of this. So the square and the square root cancel out. All right, the next thing about your calculators is it's kind of like a cheat sheet. If you rule out plus, minus, multiply, and divide, right, you look at all the other things on there, whatever you have a key for, the second function of it undoes it. Right? So it's kind of like a little cheat sheet. So if you look at square root will undo it. All right, if you look at sine, this inverse sign will undo it. Okay, and that's pretty much how they all work. Like when we do logarithms at the end of the year, natural log is undone by an e to the x. Right? They all undo themselves. So it's kind of like a little cheat sheet on your calculator. Right? So if I want to undo a square, we square root that whole side and make it cancel out. Kind of?
Yeah.
All right, so rules or steps for completing the square. Right, first thing you want to do is divide the b term by 2. Right, so when you're trying to decide what you want to make your new c term be, these are the steps to go through. So first thing you want to take is your b term. So in this case was a 10. So we would divide it by 2. So that would give us 5 in this one. The next thing you want to do is square the result of step number 1. Right, so we took our b term, we divided it by 2, we got 5, and then we square it. So what's that get us? Oh my gosh.
Sorry.
I took the b term, right, which was 10. I divided it by 2.
5.
Squared it.
25.
25. All right. Hang on a second. I need to take all of that.
Oh, you can get
happened here?
She dropped the hall pass with the plumbing thing.
Oh,
It
okay.
fell off and some shit came in.
Got it. Okay. Right, step number 3, it says make C the result of step 2. So what we ended up with step 2 was a 25, so we just turned our C term into that 25. Then we had to balance the equation. Because I added 25 to the left side, or 28 to the left side, that means I had to add 28 to the other side so that my equation stayed balanced. Then you get X alone. All right. You gonna make it? I'm worried about you. All right. So when I have a problem like this one does not lend itself quite as easily to doing that because it doesn't look like the first equation or my first example there. What's the biggest difference?
3.
Yeah, I have a 3 as a leading coefficient there. Right, completing the square works a heck of a lot better when the leading coefficient is 1.
Get rid of it.
Okay, well, the good thing news is all 3 of these terms are divisible by 3. So if I undistribute out a 3 first, what will I be left with there?
X squared minus 2 plus 6.
2x plus 6. Yep, because I just pulled out the 3. All right, now, will this thing factor?
Multiply by 3 is not 6.
12 divided, that's right.
Sorry.
12 divided by 3 is 4. I'm too trusting. Now, will that factor? Is there anything you can multiply together to get 4 that will add together to get me 2? No, unfortunately not. So this one's not going to factor, but we can try to complete the square here. So if I take my b term, which is 2, half it, square it, 1. So I'm going to turn this 4 into a 1. I'll have x squared minus 2x plus 1. Now,
So you subtract
kind of. How did I get from here to here? Okay. So that you would be telling me to subtract 3 from this side then, right? But I didn't really subtract a 3. What did I subtract? No. I actually subtracted more than a 3.
9.
Yep, why?
Because you have to multiply all the whole thing by 3.
Right. I subtracted a 3 inside my parentheses, but that's really a 3 times that negative 3. So I subtracted, it's 9. Good. All right, so it's trying to pull out something in order to get your inside your parentheses to look like something that you can actually complete the square with. That's great. But don't forget that you pulled it out. Right? So that when you go back to fix it and balance your equation, it's really inside something more. Okay, so now this thing inside the blue parentheses, I still got my 3 out here, but I should be able to factor this now. What's this going to factor into? An x and an x assigned? Okay, and that's convenient because I can rewrite that as. Okay. And now I'm down to just having an x that I can solve for. Before that. No, I don't want to distribute that 3. Plus I can't because it's squared.
Get rid of the square.
I can get rid of the 3. It's a 3 times that. So how would you undo 3 times?
Divide
Divide everything by 3 first. So now I've got an x minus 1 squared equals negative 3. Now I can square it. So on the left side, what will I get?
X minus 1.
And on the other side, what is the square root of negative 3? We know better. Because I can't take the square root of a negative.
Negative 1 square root.
No? Now, is there any...
Negative 1 or 3 and negative 1.
3 and negative 1, and square root of negative 1 is
Positive. Or I.
I, so I'm going to get I square root of 3, and it's plus or minus, so I get the square root of it.
We add the 1.
Add 1. So x is going to come out to be 1 plus or minus I square root of 3.
Boom. And the word's split screen. Boom.
That's what's up.
Today's next one's down.
It's the English test.
No, it's just okay.
All right, now, we're going to learn some other things here about completing the square. Because right now, when we did the first example, doesn't completing the square seem like the best thing ever?
Oh, yeah.
Right, and then you do this next example that's kind of like, completing a square is kind of all right. It's got some tricks to it now. And then we do example 3 here, and completing the square sucks. Okay?